Hello Info-Person, this is Anton, and in this video we're going to discuss this somewhat intriguing new study that essentially focuses on one of the biggest tragedies in Europe in the last 1000 years. We're talking about the Black Death, or the massive pandemic that spread across Eurasia between 1346 and 1353, resulting in 50 million fatalities and potentially wiping out half of Europe's population in just a few years. Something that I think most of you must have heard or read about in some of the books, but something that even today is still not entirely well understood. And though we understand the societal, economic, and cultural impacts that lingered for decades, and even understand exactly what this was caused by, it was not entirely clear how and why it started, with this relatively recent intriguing study providing evidence for something nobody actually ever considered: a volcanic eruption. And so in this video we're going to discuss some of the details from the study and talk about why right now this actually makes quite a lot of sense, and of course discuss all of the evidence we have. But first let's discuss some of the basics and what we already knew from decades of research. First of all, we know exactly what caused this, and here's the main culprit: a tiny bacterium referred to as Yersinia pestis. A bacterium that even today still exists and still infects various animals around the planet. But for centuries, one of the main arguments was for how exactly this bacterium was able to spread so quickly and why it arrived exactly when it did. Specifically, why was it during those particular years and why was it so destructive very quickly? And so based on this 2025 study, apart from some of the well-established facts and confirmations of some of the things we already knew, here this very incredible interdisciplinary study, that as always you can find in the description below, suggests that the true trigger was not just fleas or rats, but as I mentioned, a massive volcanic eruption a few years prior to the pandemic. And so essentially this is going to be a story of, as the title suggests, climate change, global trade, mixed with biological agents that essentially form this perfect storm. And well, to date, this is still the deadliest pandemic and the biggest such storm in the pre-modern world. Which is of course why the study is so fascinating, with these new discoveries offering us some really exciting new clues. But I guess let's establish the main facts first and discuss what scientists have already known for several decades. First, let's identify how exactly all of this spread. Now, thanks to modern genetic analysis, mostly focusing on various skeletons discovered in mass graves from around this period, researchers definitively confirmed the presence of Yersinia pestis. As a matter of fact, this bizarre bacterium even initiated additional waves of the pandemic going all the way to the 19th century, but obviously by then it was not as deadly. But just like in a lot of other pandemics, Yersinia pestis is what's known as the zoonotic disease, meaning that it primarily lives in other animals, and its natural hosts are usually wild rodents, usually marmots and gerbils, specifically in areas like Central Asia. And here some of the previous studies have already established a very specific genetic link, pinpointing the probable original source of this infection to what's known as Tian Shan Mountains on the border between Kyrgyzstan and China. This is the beautiful location you see in this picture. But as you probably know, the key link between rodents and humans was the flea, and well, specifically the oriental rat flea. This was the most common vector of transmission. And well, here's how this generally worked. When an infected flea feeds on a host, the plague bacteria multiplies in the flea's gut, creating a kind of a blockage. And well, this blockage makes the flea super hungry. It basically starves it, driving it to feed aggressively on anything it can find. And as it feeds on other creatures, including of course humans, it naturally regurgitates thousands of these bacteria into the blood of the victim, with the bacteria then entering the host's bloodstream, causing a new infection. And while to date most of the research essentially focused on understanding fleas and bacteria and their overall connection to various rodents around the time. Most of the focus was on rat fleas that most likely spread through Europe pretty quickly. But here, the actual spread was just a little bit faster than expected, or at least compared to what's usually predicted in various pandemics. Although sometimes it actually spread faster because it eventually became transmittable person to person through a development of what's known as the pneumonic plague. But technically all of these questions have been tackled before, and so here there's no real mystery. But there was actually one question that nobody could answer. Why exactly did this Central Asian pathogen very suddenly explode across Europe exactly in 1347 CE? Why this particular year, and why not before? or possibly after. And turns out we might actually have a very specific answer based on the evidence of what happened just a few years prior. Here, there might have been a very specific climatic turmoil that resulted in a very specific crisis, specifically the earlier famine. Okay, we need to talk about some historical context here, just so that everything makes sense. And well, it all essentially starts with the 14th century Italian city-states, with the famous ones being Florence, Genoa, and Venice. At this time, many of these city-states were rapidly growing and highly urbanized, and essentially established a bunch of trade routes going across the entire Mediterranean. But because they were highly urbanized and basically were almost like these city islands without any agricultural land, none of these states could feed themselves. They depended on trade and a lot of imports. In some sense, you can compare it to something like Singapore today. And so Florence, Genoa, and Venice heavily relied on grain imports to ensure food security. But all three states established extremely complex trade routes and trade posts across several many locations in Mediterranean and even the Black Sea. So here they had access to different regions and different locations, with their overall trade routes being super efficient, able to prevent anything like famine relatively quickly by just importing massive amounts of food from somewhere else. And so even though other kingdoms or other countries experienced famine during this time, none of these city-states did. Their trade networks were super efficient. And well, one of the main discoveries in this study is that there was actually an intense famine just a couple of years prior, during the late Middle Ages. And so here this immense famine, marked by severe shortages and price hikes in various grains across the Mediterranean, mostly affected large areas in Spain, France, and Italy between 1345 and 1347. This is actually not the same as the Great Famine that happened 2 decades prior and mostly affected the Northern Europe. But in this case, the widespread nature of this food crisis was not entirely clear. Here it was difficult to explain why these regions that are usually extremely productive when it comes to food suddenly experienced so much agricultural failure. Intriguingly here, based on some of the historical documents, scientists even discovered that the prices of grains increased dramatically, suggesting a dramatic shortage in grain. But as you can see from this graph, they discovered something else. Here they discovered a dramatic cooling event, essentially implying that in this case, this food crisis might have been the result of a larger climatic change and not just some kind of a local problem or just economics. And so this is where this volcano idea comes in. In this case, new research argues that an unidentified but very large tropical volcanic eruption, or possibly even a cluster of eruptions around 1345 CE, most likely injected huge amounts of sulfur into the atmosphere, which suddenly cooled the planet. And in this case, the amount of sulfur was possibly twice as much as the famous eruption in 1991 of the Mount Pinatubo, whose eruption was so intense and so powerful that it managed to cool the planet by almost half a degree for at least a few years. And so in this case, we're talking about something that's even more extreme. And so by injecting sulfur into the stratosphere and by forming haze that partially blocks sunlight and then causes temperature drops, here this study argues that this volcanically forced cooling potentially led to severe climatic changes in those regions and to extreme wet climate conditions between 1345 and 1347 across most of the southern Europe. And when it comes to historical observations, some of the observers in Europe and Asia did report reduced sunshine and increased cloudiness during this time, somewhat consistent with a large volcanic aerosol layer that would have formed around the time. And so here this climatic anomaly would have decimated local harvests, potentially leading to these massive famines across the region. And so with a lot of local and regional foods becoming unavailable, cities like Venice and Genoa were most likely forced to activate their emergency long-distance supply networks. And while specifically in 1347, they seem to have lifted a trade embargo on the Mongols, rushing their ships to the northern Black Sea coast in order to acquire grain at any cost. And well, this study now argues that it was very likely this grain transfer from these regions that then created a perfect highway for Yersinia pestis, or the plague. And so here the infected fleas transported in the grain cargo would return to various Italian harbors around the second half of 1347, which is exactly when some of the first human plague cases were finally reported. And so here we can actually compare the trade routes with some of the first reported infections around the region. And so the irony in this case is that this very sophisticated trade network that was specifically designed to protect these city-states from famine inadvertently resulted in a much more dangerous event. It created a perfect gateway for the plague to spread. But the reason why this study is so intriguing is because this is not just ideas and propositions. Here we do have some really intriguing climate-based evidence. And specifically, the first piece of evidence came from ice cores in Antarctica and Greenland. As you probably know, a lot of these cores act as a kind of a time capsule, telling us exactly what the climatic conditions were like, and specifically what the atmosphere was like. In this case, revealing distinct sulfur spikes around the year 1345. And this does indicate a massive sulfur-rich volcanic eruption. This is very similar to what we actually see in most of the volcanic eruption cases, so in this case it would make sense that something similar happened. But for their next piece of evidence, scientists also looked at the trees, and specifically they looked at the tree rings across Europe. And that's because the density inside these rings usually reflects the overall climate. And here the rings showed a sharp consecutive period of colder than normal temperatures between 1345 and 1347. In fact, in the Spanish Pyrenees, researchers discovered extremely rare blue rings that you see right here for both 1345 and 1346, which are normally physical signs that indicate extremely cold temperatures during this time, and specifically extremely cold summers, which would definitely explain the famine and the sudden failure of harvest around this time. But here they also looked at various documentary evidence, and specifically based on historical research, focusing on chronicles, letters, and administrative records, which essentially confirms the overall societal impact in 1345 and 1346, so basically 1 or 2 years before the pandemic began. So here this includes reports of reduced sunlight and cloudy skies in Europe and Asia, poor grape harvest or even failure of harvest, as well as heavy rain and even flooding in Italy, and of course the spikes in prices across the region. As a matter of fact, the grain reached its highest price in 1347, and so by August 1347, Venice declared a food emergency, ordering its agents in Constantinople to acquire grain at any cost from anywhere. Which is exactly what the agents did, unfortunately also bringing something else back that I guess nobody expected. And so by mapping these different data types, researchers could chronologically link various events, coming to the overall conclusion that it was very likely the eruption that began this whole process. With this model also explaining why some major self-sufficient cities like Rome and Milan seem to have mostly avoided the first wave, because they were not forced to use the same routes, especially the plague-infected Black Sea routes, that a lot of the other city-states relied on. And so basically this kind of explains this heat map when it comes to some of the first infections. And so honestly, this is a pretty strong study. It definitely shows us how one single event potentially resulted in this cascade of different events, eventually resulting in the deadliest pandemic on the planet. And specifically demonstrating that this was not just some kind of a simple accident, but instead was a very complex interaction of climate, famine, disease, and global trade. And so it was really the result of this very sophisticated food network established by some of these Italian city-states. Although I guess the irony here is that they tried to protect themselves from famine and instead caused something even deadlier. And so here, by looking back at the Black Death, we essentially have a perfect example of how global systems can turn against us. And so being prepared for these health risks is actually kind of sort of important. Now I think so far we did pretty good during COVID, although I guess we could have done better. But it's really that next pandemic that's a little bit worrisome. Not if, but when it happens, are we actually going to be okay? Anyway, let's not end this on a gloomy note and instead remember that it could have been so much worse. I mean, look at what happened here. This killed half of European population. Yeah, so thanks to biomedical fields and thanks to quick response times, we're definitely getting better at trying to tackle these pandemics. Anyway, this is definitely a super cool study and I really enjoyed reading it, and if you want to check it out, it's free in the description below. We'll come back and discuss this more if there's some additional updates. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support the channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.